Hello everyone and welcome back to Introduction to Number Theory. This time we'll discuss a more general case of a linear Diophantine equation in with two unknowns. Here we see a linear Diophantine equation, x and y are unknowns and a, b and c are some integers. What if a and b are not mutually prime? Well, in this case, ax is divisible by the greatest common divisor of a and b. And by is also divisible by the greatest common divisor of a and b. So c, being a sum of these two summands, must also be divisible by the greatest common divisor of a and b. So we understand that if a and b coefficients upon x and y are not mutually prime, then c must be divisible by their greatest common divisor. This is a very important condition because it is necessary to be fulfilled in order for the Diophantine equation to have at least one solution. So it is necessary, but we do not yet know whether it is sufficient. Let's see what is the structure of solutions of this equation in case a and b are not mutually prime. Well, if all of them are divisible by the greatest common divisor of a and b, then why don't we just simplify this equation and divide it by the GCD of a and b. We will have a over this GCD plus b over the greatest common divisor of a and b multiplied by y equal to c divided by the greatest common divisor of a and b. In this equation, the coefficients upon x and y are mutually prime. This one and this one. Well, since we divided a and b by their greatest common divisor, then these two are mutually prime. So we can apply a formula from the previous video and say that x is equal to some particular solution plus b over ab multiplied by t, and y is equal to some particular solution corresponding to x1, of course, minus a over ab multiplied by t, where t is an arbitrary integer. Once again, notice that these signs must be such that when we substitute this formula into the equation, these parts containing t simply disappear. So if we have here plus and plus, then we need to take plus and minus. And in case that in our original equation we had plus here and minus here, for instance, then we would use the same signs here. And it doesn't matter whether we use both pluses or both minuses. This is the general formula for, these are the general formula for the solution of a Diophantine equation, Diophantine linear equation with two unknowns. And now we know that this is the necessary solution for the necessary condition for an equation to have a solution. Is it sufficient? The answer is positive. Yes, this is the sufficient condition. And let's show this. Let's show that if c is divisible by the greatest common divisor of a and b, then such linear Diophantine equation has a solution, an integer solution, of course. It is well known that the greatest common divisor can be represented in the linear form. So there exists such integer k and m that this equality holds. K and m are some integers. This is the linear representation of the greatest common divisor. Then just multiply this equality by c over a and b, which is integer since c is divisible by the greatest common divisor of a and b. We multiply it and obtain an equality of the form a multiplied by k c b plus b multiplied by m c a b. Well, it seems complicated, but it's not. This is equal to c. So we see that there exist integer numbers. Denote this one by x1 and denote this one by y1. And we understand that k is an integer and this fraction is an integer, so x1 is an integer and so is y1. And here we see that there is a solution of our initial Diophantine equation, and we know that if there is one solution of such an equation, there are infinitely many solutions. And there is a solution if and only if C is divisible by the greatest common divisor of A and B. It is a necessary and sufficient condition.